Smashing. Okay, so firstly, thanks for Alex dropping me an email and inviting me to come and speak. It's actually quite topical and interesting to be back in Cambridge again, because the last time I was here was probably about 3 or 4 years ago, over the road, speaking to some people in BioVia about we were there for 4 days implementing an interface between an open source software library that I developed when I was in Edinburgh and a part of the Material Studio product. In actual fact, that was exactly the case that kind of Judith was talking about embedding something in a commercial product. In our case, that didn't actually happen in the end because the kind of internal champion for doing that piece of work, I think, moved on to another company or something. So they kind of there was nobody there to drive it from their end, and it didn't work out for that reason. But from an implementation point of view, of course, it all worked perfectly well. So given that I was asked to kind of talk about open source software and business models related to open source software, I thought I'd kind of, what does a business model mean for an open source or for open source software development? I don't think this is necessarily limited to commercialization of open source software, but just in general, how does an open source software project sustain itself from a funding point of view? And I thought I'd also kind of steer that a little bit towards commercial adoption of open source software. So before I start, I'll give a quick, a two-slide advert, one for context and one is some recruitment, which is very relevant for today. So the organization I work in is the STFC Hartree Centre. So STFC is one of the research councils that fund research in the UK, and so they fund research in areas of astrophysics, particle physics, nuclear physics, and I'm sure something else I've forgotten. But they also run national labs and large facilities, things like particle accelerators, radio telescopes, the UK's contribution to some of the programs at CERN, for example, and they also run some high-performance computing services. The particular part of STFC that I work in, which is the Hartree Centre, has this as its mission statement. This is transform UK industry, so it's very, very tightly focused on industry-facing applications, by accelerating the adoption of HPC, and so modeling and simulation software, not necessarily materials, but across a whole range of different areas, big data and AI technologies. And so we're basically a technology transfer organization. So hopefully, in that role in the last 2 years, I've learned some things that are relevant for this meeting. Now, the job advert, which is very topical. So we actually have, if you know or any of you are interested in a new role, for the next week till the closing date, and we're trying to hire somebody who's going to work with me to do this, identifying commercial opportunities arising from research activities and exploit these through licensing and spin-outs. So basically, if you're here because you're interested in this kind of topic, we'd love to, we'd love to hire you. But in all seriousness, share it with your friends, because this is something which has been part of my role in the last 2 years, which I haven't had the time to focus on, because I'm doing a whole bunch of other things as well, and this really is a full-time person to focus on. So please share the link. I don't know if the slides will be made available or whatever. Okay. So what I'm going to talk about, I'm going to start with a bit of background and context on open source software licenses. Some of this has already been covered already. I'm going to go into a little bit more detail maybe. I'm now going to talk through some general, what I call kind of business models or ways in which open source software projects can sustain themselves. These are not everything. They're not necessarily distinct categories, but they'll give some of the ways in which open source software projects can sustain themselves. And I'm going to talk through 2 case studies, one which is a materials modeling software package, CP2K, that I've worked on for about 10 years, and one which is the program Innovation Return on Research, which is a technology transfer program that I manage at Hartree Centre. So that was not so much about the development of open source software, but how open source software plays into an ecosystem where we're trying to commercialize and find commercial applications for software. So I'm going to caveat all this by saying that I am not a lawyer, but I have spent enough time talking to lawyers that I do understand most of the issues involved. You're laughing at the acronym, okay. This is a well-recognized acronym, just don't Google it, okay? Or at least not while you're at work. Okay, so some kind of principles. Why is open source software so popular in academia? It kind of comes from the founding principle of open science, open research, right? So there's various flavors of this, including open access publication, open data, and open source software. So the kind of underlying principle is that science outputs should be freely accessible to everybody. This is so I'm just postulating this is one principle under which many academics operate as a foundational point of view. It's not necessarily always has to be the case, but it's this sort of altruistic principle that scientific research is for the greater good. The things that I do in my day-to-day job as an academic researcher should be for the benefit of all mankind, with no hindrance of access. You have to be a member of a club to access it. You have to be in a university. You have to pay for access. It should be freely available for everybody. So that's one principle by which open science leads to the use of open source. Some other principles are things that that might be drivers for academics who are developing software. So the principle of demonstrating that your work has academic impact. So it makes a difference to other academics. It's not just for your own idle curiosity. So maybe from a software point of view, does greater impact mean more users of your code, and how does licensing and your business model that you take to your software affect that? How do you measure it? This is a really important question when it comes to choice of license and how you do licensing. I should say, actually, I'm going to probably ask more questions in this talk than I am going to give answers, because there is no one-size-fits-all answer. And I think, given the number of people we've got in the room, actually, I think the discussion is going to be as interesting as the talk. So lots of questions in here. The other thing the other kind of impact that, at least in the UK, all academics are being asked to demonstrate that they have is that their research has industry impact. And so essentially the funding that the government puts into academic research somehow translates at some point in the indefinite future into impact on the UK's GDP. So turning research into industry productivity. So people are being asked to produce things like impact case studies for the REF academic ranking exercise. But if you want to do that, and actually to do that well implies certain things in how you license your software, that maybe introduces some more complex IP considerations than if you're just wanting to increase the number of users. So there are trade-offs to be made in here. So the point is that the choice of licensing model that you make is kind of a compromise between maybe your values and what you want to get out in terms of impact from your research. Okay, so that's some principles that you might operate under. When we talk about open source software, what do we really mean? Okay, so it's a very, it sounds like it kind of should be obvious, and we'll see, I quite often ask this in interviews to people, what do you think open source software means? And quite often people say, well, it means I can access the source code. Well, that's part of it, but that's not all of it. And this is actually it's a complicated area. The open source is a term which is bandied around. Free software is a term which is bandied around. So there's the open source initiative, who talk about open source software. There's the Free Software Foundation and the GNU organization that talk about free software. So in actual fact, people tend to just go, well, it's free and open source software. There are subtle distinctions between the two, but to be honest, for the purpose of this discussion at least, the freedoms that we care about in both cases are these. So both open source and free software have freedom for people to use the software irrespective of their purpose in using it, so not placing any restriction on what the software can be used for. Freedom to modify the software, so that implies having access to the source code so that they can make changes to it. And also freedom to redistribute the software, including modified versions or derived versions based on the software. So those are probably, I would say, the three sort of fundamental freedoms that both open source and free software share. And just as a way of thinking about it, you may have heard this analogy before, free software, we're talking about freedom as in speech, right? So without restriction, as opposed to freedom as in beer, where beer comes at, free beer is beer at no cost, okay? So open source and free software say nothing at all about cost, and what they do say is about freedom, okay? So in actual fact, I think the point I was made earlier that the GPL says you can't sell that software is not true. It places some restrictions on the company that make it difficult for them to sell software. It doesn't in and of itself stop them from selling the software, okay? So these are I'm going to go in a little bit more detail than in the previous talk about the two kind of classes of software licenses. And actually, before we do this, because there was some, in one of the Q&As earlier on, there's some sort of talk about copyright and what does that mean. So just stepping back actually before licenses, whenever you write something, whether it's a book, a play, a piece of music, or a piece of software, you as the author can assert your copyright in that piece of work. And what copyright law in the UK at least says is that all the rights that the author has, so the rights to use that work, to copy that work, to distribute that work, to perform that work, are reserved to you. So if you don't choose to do anything else, your software is copyright to the author. That protection normally lasts, at least for software, from 70 years after you die, if you're the author. And until that point, all those rights that the author has are reserved to the author, and no one else can make use of the rights. There's actually, as was mentioned earlier, there is the distinction that for many people, at least in the UK, the standard practice universities is when you write a piece of software or any other work in the university is the copyright owner. So that's something, again, that's, in that case, actually the copyright lasts from 70 years, I think, from the point the software is put into is published. So actually, you're often not the author of your own work if you're working in a UK university. And so that's the default position. You see, copyright, the University of Edinburgh, all rights reserved. That's the default position. It says the University of Edinburgh is the only entity that has the right to distribute, use the software, etc. And what a license does is it then grants some of those rights from the copyright holder to other people. And so that's the format of the license. You'll see at the top, it'll assert who the copyright holder is, and the terms of the license say which of those rights that normally are reserved to the copyright holder are granted to other people. So examples of open source licenses, and what do they mean? So the permissive licenses that I mentioned earlier, the most common examples being the MIT and BSD licenses. So they're permissive because they grant a lot of rights to the person obtaining the software. So typically of most open source softwares, one of the things they also do, open source software licenses, they disclaim liability and warranty. So you'll see this phrase of the software is obtained as is. You get the source code, there's no implied warranty that it's fit for any purpose at all, even what it says that it should do. It doesn't imply that there's no guarantee, and you can't hold the copyright owner liable if it doesn't perform what it says it does or people think it should do. But here are some of the permissions that are granted. So permissions to use and modify for any purpose, fair enough, open source. Permission to redistribute, and it's a permissive license that includes redistributing this software under another license term. Usually there's some kind of caveat here that says the existing copyright and permission notice must be retained. So you can take that software, you can include it as part of a larger work, you can bundle it under another license term, you have a commercial proprietary license containing that software, provided that you retain the note that says this is originally copyright whoever the author was. And there's various variants. The things say you can't use the name of the copyright holder to endorse the work. You can't produce a derived version of something and say, based on this amazing work from Massachusetts Institute of Technology, you wouldn't be allowed to do that, or it might require some form of acknowledgement. And so these are the permissive licenses. Okay, so they basically allow somebody to take the software and do more or less whatever they like with it. At the other end of the scale of the open source license are these so-called copyleft licenses. So these are they're called copyleft because in some sense it's the opposite of copyright. It's not about retaining rights, but about making rights open. So similar to no liabilities, no warranty, permission to use and modify for whatever purposes, grants permission to redistribute, and then this is the nub of the issue around these licenses here, is it grants permission to redistribute under the same license. So if your software is licensed as GPL, and then you modify it to create some derived work, the whole of the derived work. Or if you take that software and you incorporate it with some other piece of code, then that whole code forms a derived work and the GPL license applies. And what the GPL license says is that when you distribute that derived work, you also have to give access to the source code. And so there's nothing in there that says that you can't form a derived work and sell it to somebody, but when you sell it to them, you have to make the source code available. And the trouble that creates for businesses is that it means in principle somebody can then take that open source code and give it away for free, basically undercutting their for-profit business model. Now, in practice, there's a whole bunch of companies that do sell GPL software, and the reason they're able to do so, well, there's a couple of reasons. One is either they have a business model where they actually basically give the software for free and sell services around the software, or they sell a user interface on top of the GPL software or something like that. It might just be the case that actually to make use of the software is so complex that there's a value add that somebody's prepared to pay for, even if they have access potentially to the software for free. Buying it from someone as a package solution is still a better investment for them. And the various variants, so the GPL is what I talked through there. So basically, any form of combination of that software into a single derived work triggers this, what's called the sort of viral properties of the GPL. Then there's other, so like the lesser or library GPL, which says you can create a library licensed under LGPL and then link a code to that, and the license doesn't apply to the whole thing. So there's kind of different, or the Mozilla public license, which says you can take a single file of source code that has that license, and you can form a derived work as long as you keep it in separate source files, for example. So there are different degrees, if you like, of virality of these kind of licenses. But that's the so those are your kind of two, as I said earlier, two kind of options, roughly speaking, when you're looking at open source software licenses. So this is a software license which is not an open source software license, but it's something that we use, we've developed at STFC. It's called the UKRI academic license. The UK Research and Innovation is the umbrella organization that now contains STFC. So in many ways, this looks like an open source license, but it's not exactly, because it doesn't preserve all of the freedoms that I mentioned earlier. So the software is provided as is. It grants permission to use and modify the software, but for academic purposes only. So one of the freedoms that the free software and open source software movements espouse is that you should be able to use it for whatever you like. In this case, we're saying you can only use the software for free if you do it for academic purposes. So essentially, if you're a researcher of some flavor. It also doesn't provide any permission to redistribute the software. So whenever someone accesses that software, they're accepting the license agreement. That gives them personally a right to use the software. They're bound by the conditions of the license. And they can't redistribute it to their friends. It allows us to retain some control over what's in the software. There's no endorsement things. You can't say, I've done something based on our work. Yeah, so this is not an open source software license, but what it does allow us to do is it does allow us to publish source code. So for example, you can find software projects that we've published on GitHub that have this license here, and that works really well for example, so we've got software in the bioinformatics space, where the expectation is that the softwares are open source, and that people can do, conda install package name, it pulls down from the repository automatically and installs. it doesn't fit well to the the older business model that STFC used to use for software like DL Poly and DL Meso, where you have to go onto a website, maybe click a link to accept a license agreement, then you get a zip file with the source code. That wouldn't work for those kind of communities that expect the code to be available. So this is kind of like a halfway house whereby we can have the code up in public, but the license restricts the purposes for which it can be used. And there's a thing in there that says, if you want to use this code for commercial purposes, that's fine, contact us and we'll give you a commercial license, which actually has basically the same set of terms, but will also have a cost that the company who wants to use it for commercial purposes has to pay. So that's like another sort of halfway house business model that we use, that gives academics freedom to use the software at no cost, allows us to retain control over what's in the source code, and allows us to profit from commercial use of the software. So that was the kind of backgroundy bit. The kind of business models. So I said that I was thinking of business model being how can an open source software project sustain itself, that being the kind of key aim, funding to sustain development of the software. I think it's been recognized very few people are going to make, in the academic world, are going to make themselves rich through software. But when you're thinking about what kind of business model to choose or to use, what is it you're looking for? Do you just want funding that's going to allow you to add new stuff into your code? Do you need to find funding for ongoing maintenance? And what scale are you thinking? Are you just basically wanting, there are some people who publish, who make money from research software, who just use it to, fund their travel to conferences, or is it just to pay my salary so I can keep my, keep my job and do my research? Or are you looking to, as a PI, fund a group of people who rely on you to bring in grant income to fund their work as well? And then these other things that I mentioned before around the kind of incentives you're aiming for is your main aim to increase the usage, the number of people using your code, or is it to create industrial impact? And some people actually, when you're thinking about how you want to structure the way you sustain your open source software project, are you interested in turning it into something that's a bit more of a product, a kind of consumable thing, or are you happy with it being a kind of a research code that's good enough to produce publication quality results that maybe doesn't have all the ease of use, consumability, reliability, and other things that were mentioned earlier as being good aspects of commercial ready software? So these are some of the things you might have to think about. What is it you want to get out of the business model? My sort of way of thinking about how open source software development could be set up. So at one end there's a sort of basically volunteer model where you're not actually really thinking where it's coming from. You're kind of leaving that up to the contributors to your software project to worry about how they're funded. You're kind of disclaiming responsibility for that. So there's kind of two flavors to that. One is what I call the kind of lone wolf developer. So this is a software project where I'm the only developer, basically, right? Now this clearly has the advantage that there's very minimal requirements for funding. It's just me. I might even do it in my spare time. I might even do it in my evenings and weekends. Disadvantage of that, of course, is I have software projects that I work on like this. They're like my hobby projects, things that I carried over from when I was a real academic before I became a government employee. And the thing with that is, I know I've got bug reports in my inbox that have been there for a month that I haven't looked at yet, right? Because it's not my day job. So that's the kind of the quid pro quo there. But on the other hand, I can continue working on the projects that I like without having to find any funding for it. And then, of course, this is the reality of it, right? GitHub is littered with software in people's personal repositories that hasn't been updated for 5 years. There might be somebody in some university on the other side of the world that relies on your software, and there's nobody maintaining it, right? I mean, it is open source. They can pick it up. They can understand how the code works, and they can maintain it themselves. But Maybe I'm not going to do it anymore. You know, I've got a whole bunch of projects like this that I've walked away from because I don't have any interest anymore, and I know they're just sitting there, and I hope nobody's relying on them, but maybe they are. The kind of classic open source development model, you know, this is still a volunteer-driven thing. It's community development, okay? So the source code is open, lots of people can contribute. I think this is also kind of related to the academic software model of development by students, right? So this is basically lots of more or less independent people who you maybe don't have any real control over kind of what they produce, when they produce it. You know, people add the features they care about into the package. So you can quite often end up with a piece of software that's kind of like you know, it's kind of everything in the kitchen sink all lumped together into one ugly conglomerate because people have just glued on the bits that they want to make it work, okay? And it also has this kind of, you know, development can be quite bursty. Somebody, a volunteer somewhere, gets really motivated and spends a lot of time over a period of a few weeks doing lots of work on the code and then moves away again. And maybe they put things into there that no one else understands, right? So there's lots of issues around this. The thing that's actually kind of hidden in this, you know, it's community development, it's done by volunteers, it's for free. If you're the kind of maintainer of a software package, there's a really high overhead, potentially a high overhead on you, that's not really you know, widely known, because you need to kind of merge all these contributions in to make a coherent software package. You know, otherwise, I've worked with you know, research groups who develop, you know, this kind of development by students. They have an open source software. A student will come in, they'll develop a new version of the software, and they'll come on, they'll develop a new version of the software, and nobody is maintaining it and merging all these things together. So actually, when you go to the repository, what you find is you find 12 different branches, all of which have subtly different functionality. And if you take the same input file into 2 different branches, it'll give you 2 different results. And which one's right? Well, yeah, go read the code. It's open source, right? So there's a real overhead in here that you know, is maybe a reason why this, at least by itself, this community development model, you know, might be difficult. So the grant-funded model, I guess this is the way that probably the majority of academic software is developed to some extent. So we're thinking about there actually being some funding that's obtained through an academic research grant has been obtained to help develop this software. So, you know, this gives you some advantages over the volunteer model. So, you know, staff, at least somebody is working on this grant. It's their responsibility to develop the software. Okay, so somebody has at least some ability for a period of time to focus on the development of things. It gets away from the burstiness or the it's done in my spare time, so it's only when I actually have some spare time issues with the volunteer model. The downside of it, of course, is that actually grant funding to just do software development is relatively rare, okay? And grants for doing maintenance of legacy software are even rarer, okay? So these are things that are both picked up in the survey data that you shared at the beginning that people, you know, academic software have to do, but how do they fund them? So typically how they fund them is they apply for research grants to build some new bit of functionality to do something which is topical and it's a novel application that will lead to a publication. And then they may or may not do the maintenance bits alongside, okay? So this, you know, doing it that way, which is sort of shoehorning all your software development into a research grant that's doing new stuff, sometimes leads to actually just accumulation of the technical debt that Mike talked about. There are some funding streams that do allow you to do kind of software-specific things. So things like in the UK, the National HPC Service for several years has had schemes which you know, has funded development in CASTEP, for example, and many of the other major academic codes. In Europe, you know, PRACE has schemes that do this, and these are actually really nice schemes for allowing you to do things like code porting, performance improvements, things that are necessary for a code to develop over a long period of time, but you know, they're not going to, in and of themselves, win a research grant. The downside of them is they're quite often short, like 3 or 6 month projects. So there's actually a relatively high overhead. If you're the PI or the kind of lead software developer, you might spend your time writing quite a lot of proposals to get this kind of funding in. So this is the kind of model that to some extent or other, a lot of UK academic software is developed under. May also accept community contributions as well. So these are not, they're not, as I said earlier, they're not different exclusive models, but maybe with some core funding along these lines, you can then start to accept in community contributions as well. So the license-supported model we've talked about already today. Clearly, speaking to whoever is your technology transfer office, the relevant part of your university, about how to do this is really important. I should say that actually, before you put any code in the public domain under any license, open source or a commercial proprietary license, you talk to them anyways, because, as I said, you're probably not the copyright owner of the code. You don't actually have the legal right to grant those rights. If you put your code up on GitHub that says, copyright your employer, the university I work for grants all these rights to everybody in the world, you're putting yourself in a bit of a legally dubious position there. So always go and talk to these people before you push anything out under any license. This is pretty much a summary of kind of the kind of things, kind of license fee supported models that there are. Perpetual license to specific code versions. So you buy a license to code version 3, and they give you version 3.1 or 3.2 and 3.3 with the bug fixes for free. This is what VASP, Amber, a whole bunch of other packages do. There are some sort of hybrid models where you might have to pay for some particular version of the software, and so in DL Poly, so that's available from STFC. You can get the latest version of DL Poly 4 on a paid-for license. The DL Poly Classic's available for free. In Amber, if you want the fast parallel version that supports GPUs, you pay the license fee. If you want the CPU slower, older version, Amber Tools, you get that for free. Or you maybe do the same thing like the UKRI academic license does, or has been talked about for CASTEP. You have some kind of free for some users and not free for others. So there's, how much money these methods bring in is very dependent on the size of the user base, etc., and the license fee, of course. Because VASP, you're talking thousands of dollars per research group per year, whereas Amber is like, I bought a license a few versions ago, and it's like $500 or something like that for a perpetual license. Okay, so I just wanted to share a couple of quick kind of case studies that I think are relevant to this conversation. So one is the CP2K software, which has been around for nearly 20 years. It's an open source community software project. So I'm not going to go through the basics of DFT. That's already been done by someone much more qualified than me. But CP2K, among other things, is a DFT code. Its kind of USP, if you like, is this dual basis approach that makes it a linear scaling code. Okay, so this is actually a quotation from the original homepage back in 2004, remained unchanged for the last 15 years. So it kind of jokingly called CP2K, it originally comes from Zurich, so called the Swiss Army knife simulation. Unfortunately, it's become a little bit like this. It's kind of has a lot of things in it, and it's not immediately obvious that you'll be able to use it without cutting your hand off. But it is getting better. I spent a lot of time over the last 10 years putting safety catches on the Swiss Army knife. Okay. Yeah. So. Just a sort of very kind of brief history. This code came from just after the turn of the millennium, from a merger of a density functional theory code that could do energy evaluations and an MD code. Put the two together, and you've got a Born-Oppenheimer MD code that's pretty efficient for moderate to large system sizes. But 10 years of development before the first official release, although the code was public right from the beginning. And where is it now, nearly 20 years on? It's like 1 million lines of Fortran, something like that. I think there is probably about 4 of us in the world who understand more than 50% of it, but not much more than 50% of it. Hopefully, between us, we understand all of it, but that's not a given. They're currently active, probably about 20-odd developers and many more contributors. So this is it is open source code. It's licensed under the GNU GPL, so it's one of these copyleft. Very much came from the sort of dogmatically everything shall be free and remain free open source community. So there it is. It's there in the GPL. It has thousands or tens of thousands of users. One of the disadvantages, of course, of open source licensing is you have no way of knowing. Nobody has to go through a process whereby they accept your license agreement and register. They just download it and accept the terms implicitly. So it's very hard to track exactly how many users you've got. We did have some numbers which I used to show, at least from the on the UK National HPC service. The #1 code with like about 25 to 30% of all the CPU cycles on the HPC was VASP. CP2K was quite often #2 or 3, and then CASTEP was in the sort of top 4, 5, 6 thereabouts. I haven't seen those numbers for a couple of years. So these are kind of major software package. If you care to know more about what it does, go and have a look at the website. It's been used for lots of high-profile applications. But rely on people spreading the word and citing the papers. That's the only way that we could justify further development and further funding for the code. So it took a long time to get to that kind of critical mass of people knowing about it and using it that made the development sustainable. Who are these developers? I just want to give you a kind of feel for how this community kind of works. So the lead kind of development group is at the University of Zurich. So this is Jörg Hutter, who's of course involved right back from the early days of the car parallel method and some of the early implementations of that. In his group at the moment, he's got 3 senior researchers, a pile of postdocs, PhD students and master's students, all of whom contribute to the code development. One of his former senior researchers had a group for a while at ETH Zurich, and then there's a whole bunch of other groups that kind of come and go around the world. So at the moment in the UK, Matt Watkins' group at Lincoln has a few developers working on the code. Paderborn. When I was there at EPCC, and there's people that contribute from IBM Research. The whole code itself actually is governed. This is a legal entity founded in Zurich called the CP2K Foundation that's there to kind of govern, promote, and protect the kind of open status of the code. So there's a whole range. This is researchers working in university research groups who are developing a community open source project as a side effect of their research work. How is it funded? So basically, I'd say there's kind of 3 main ways, right? So there are a whole bunch of large platform grants that have been able to, over a period of 20 years, have sustained the development of this. So the Swiss national HPC programs, HP2C and PASC, these are things that have given maybe a 5-year duration funding for a couple of people to develop the code. Up to last year, I had a 5-year grant that we got through EPSRC. There was a software development program grant that allowed it. What these grants really do is they divorce the need to be producing new stuff and allow you to do good software engineering on a code without having to produce new research. And so things like refactoring the code to have a high-scaling sparse matrix implementation in there, that's something that wouldn't be possible to do without these kind of platform grants. The software development funding for performance improvements, improving code quality, these things have been really, really helpful, but they're very, I think over time I've probably had about 6 or 7 of these kind of short 6 months up to a year maybe software development projects that have contributed to CP2K development. And then of course there still is the model of a research grant where somebody's developing a new method, it gets implemented in the code and they do some software development on the side. And we do still get, random bloke in Croatia suddenly joins the mailing list, gets really enthusiastic, goes through all the code, puts comments in places he'll never comments before, implements some new stuff, and then disappears off into the blue yonder again, and we never hear from the guy. All of these things go together. So I think the story here is, to sustain something as large over a period of time as this, you do need, there's no one-size-fits-all, and you need a mixture of different funding opportunities. So, summary of what CP2K is, 20 years of open development definitely requires these diverse funding streams. It's a GPL licensed code, so it is open, unlike, for example, some of the other kind of competitor packages like the CPMD package, which has, if you go on the website, the CPMD free license. It's not a piece of free software. It's owned by IBM and the license tightly controlled by them. I think from a cultural point of view, there's a few things that work really well here. One is that anybody who comes into one of these groups that develops the code, whether they're a master's student or whatever, they immediately become kind of part of the developer group and feel that part of their task is to improve the overall quality of the software. It's not just that they're there as a student that's trying to do their PhD, which is that little notch on the edge of humanities knowledge, but as well as doing that, they're part of a community that's developing the code. And the other thing I think that's been really beneficial in this case actually is a really strong link between the user community and the developer community. This is something I really tried to do in the 5 years I had this EPSRC funding, and was to get away from it being a code which was kind of developed by some people in Zurich in an ivory tower and handed down to the users, and those two never spoke. Whereas now we have, and this kind of comes back to help with the sustainability of software. So we have users who came along to some of our user group meetings we started, who've then gone and applied for grants, where they've then written in funding in their grants to fund software, to fund development of the package. So kind of, this effort for developers to support the users then comes back because the users want to support the developers. So these things, kind of come round in a kind of karma-like way. I would say one thing that's maybe not a strength of CP2K, and it's maybe around the fact that, the GPL license is there. There has been relatively limited industry uptake of it. And we've talked to a few people about, bundling it behind a user interface like Material Studio, but it's never really taken off. So, I think this is, a real success story of sustaining open source software development with lots of academic impact, and maybe not so strong on the industry impact. That's just my take on it. So I just want to go again another quick kind of talk through kind of what's my day job now, managing this this research program called IROR. So this is not producing open source software per se, but open source software is part of the ecosystem of the program. And what's really about, it's about developing software with capital funding. So what this program is, so the name kind of tells you what it's about. Innovation, so that's applying research to solve real world problems. So getting some industry impact as a return on research investment. It's part of £115 million capital investment from the government to run this 5-year program. For those of you who've done any accounting, you'll know that money comes in two forms. Comes in resource or recurrent funding, which is what pays everybody's salaries, that you have to kind of balance on an in-year basis. And capital money, which is what the government produces when it wants to spend large amounts of money quickly and buy things or build things, okay? So if you want to spend X billion pounds building HS2, that's capital investment. If you want to build a bridge, that's capital investment. If you want to pay for people, that's not capital investment, okay? So capital investment has to produce assets. So how do you go about building software with capital money? So what we do is we use people to build digital assets, Okay, so this is actually a valid accounting practice. We have been through audit by the National Audit Office on this one, so we can take millions of pounds of government money, use it to pay for software developers and researchers to produce software. Okay, and that software that we produce is a digital asset, and it sits on STFC's books as an asset which we can then use to derive income from. So part of the program is about building the assets. We do that, so IBM Research are a partner in the program, and part of the program is also about developing business models by which companies can adopt these assets, and so they can generate benefit from them. So getting some return on the government's investment. So there's a whole bunch of things that kind of play into this, right? So there's the fact that some of the software that we build on, some of the components that we use are open source. There is IP that comes from STFC, that's owned by STFC. There's IP that comes from IBM, that's owned by them. And how these three things go together in projects to produce foreground IP is complicated. A legal document that describes how those things go together. But basically, what we're trying to do, we're trying to develop software through projects with UK companies. So we work with companies that provide us with basically a challenge statement. We develop software or pull together components to build new software that addresses their challenges. And then we look to take the software that we've developed and roll it out across a particular sector. So for example, one of the companies that we have a development agreement with in the chemistry and materials space is Unilever, but the software that we develop, the idea is those components can be reused with other companies that operate in the same sector. So that gets us around falling foul of state aid law. So we're not just building software, bespoke software for a particular company. So this is the structure of the program. I'm just going to major on the kind of chemistry and materials section of the work program, but we also have stuff going across engineering, manufacturing, and so on, the technology development. So to give you a kind of example of the kind of capabilities we're developing in the chemistry space, so we're working in this area of formulation chemistry. So this is about being able to generate computer models of how. In the case for, so Unilever, they're a fast-moving consumer goods company. Basically anything you've got in your house that's a cream, a foam, or a gel, these are the kind of things we're talking about. How can you control, you can model and control the properties of those kind of products. So what we've been doing is basically replacing their physical experiments with simulation analogs. Most importantly, putting the tools that we develop in the hands of their lab chemists. They don't need to be HPC people, they don't need to be software engineers, allowing them to basically reduce the amount of time it takes to go through their experimental design cycle. So here's what our software stack looks like. Actually, right at the bottom of the software stack, it's not even written in here, are the actual simulation engines. So these are either open source software or some of our own software, like DL-Meso, for example. So a DPD simulation package we use for a lot of this stuff. We've built workflow software. So as most of you all know, to actually get from a research question to a result, it's not just a single simulation, but often simulation setup, post-processing analysis, maybe multiple simulations. So we've got workflow software that does all that automatically for us on our HPC systems. So we're mainly talking about using DPD, particle-based simulations here. Of course, all the magic is in the interaction parameters. And unlike atomistic force fields, there's not so many kind of go-to force fields. If you're a biomolecular simulation person, you can pick charm or amber force field or whatever. Here we've developed capabilities to develop parameters for specific industry problems. So that can either be based on parameterizing against experimental data or parameterizing against ab initio calculations. Again, all automatically. And then the user interface piece that you said was earlier was quite key for getting industry to adopt software. It has to be easy for them to use. And actually, in this case, it really has to be not even for a simulation person in a company to use, but for someone who's come from a wet lab chemistry training background to use. And so what we want to be able to give our customers really is insight into their specific problems without too much effort on their part. So when I'm talking about putting stuff in the hands of the chemists, so the picture a couple of slides ago wasn't just a marketing slide of someone staring at an iPad. We have an app on an iPad that people in Unilever are using today that's running these workflows on our HPC systems. So they have an interface where they can select what particular chemicals they want to go into their formulation, what fraction of each, and then they can run things like this, which is the workflow to generate a ternary phase diagram, which will tell you, depending on which mix of these three constituents you have, whether something's going to phase separate or whether it's going to become a nice colloidal mixture. And this kind of diagram was something that we spoke to their chemists, and that's the kind of thing they would draw based on the results of physical experiments. This is what I mean about kind of making stuff really easy for them to use. So that's the kind of things we've been building. As I said, the way how we work with the companies in the program is sort of described in this slide. That basically, companies bring to us a challenge statement. Sometimes they bring to us data. That's their confidential, proprietary stuff. We'll do these projects under some kind of non-disclosure agreement. They'll share with us the data. We'll develop software, and we'll process their data through our software and give them back results that help them do whatever it is that their business does. In the case of Unilever, designing shampoos or whatever, or laundry detergents. But everything that's under this line here, this is all IP that's owned by ourselves or our program partners, IBM. So that's the kind of model we're operating in. And then, having done these kind of projects that develop these tools, the next thing is, how do we get them into the hands of the companies? Because we're not just having our altruistic for all mankind hat on here. We've got our other hat on which says, we've got these assets on our books. We need to sustain our own financial viability as a center. So what kind of business models can we derive from this valuable software that we have that will help us to sustain ourselves? So there's kind of four ways that we've thought about for doing this. So one of them is what we call our collaborative R&D. So this is basically doing paid-for projects with companies on the back of this software. So that could either be, or it could be one of two things really. One is it could be company comes to us with a particular question, a data set, we process their data, or we answer their question using the software that we've built. So it's just an outsourced R&D, if you like. Or it could be that we actually do a project to further develop the software to make it specific for them. Because if a company is paying for us to do a piece of work, we don't need to worry about state aid. We're not using government money anymore. The company's paying, they can get the IP, we can do something very specific for them. So we do these collaborative R&D projects. So that could be, as I said, the company paying, or it could be that we go in and bid for grant funding with the company. And so Innovate UK competitions, for example, are very good for this kind of thing. We also have kind of as-a-service model that we operate. So we have HPC facilities on site that we own, that companies that we work with buy time on the HPC system. So we'll have a per core hour or per node hour cost that we can charge them out at. If they want, so they can just access that as like a infrastructure as a service, so using us instead of going to Amazon Cloud, for example, or they can have a more of a sort of platform as a service offering where we'll install the software for them, and they'll pay for that at a sort of premium rate over and above the cost for compute. We do also do commercial licensing for software as well. So this is really good for so some of the companies we work with are so protective of their IP that they never want to let. So, for example, companies in the defence space, if we're doing CFD calculations for companies that design submarines or something, they don't want to ever send their geometry over to run on our HPC machines. So they want access to the software themselves, and in that case, we would put together a software licensing agreement whereby they would get rights to use and modify the software in-house. We also do have this model whereby we can have a 3-month no-cost evaluation license. This is something we find quite helpful for companies that, they see a piece of software, they think they might like it, but they don't want to invest straight off. And so this has actually been quite helpful for us. So this is often, if somebody sees a piece of software on GitHub with the UKRI academic license, and they contact us because they're a commercial organization and want to use it, first thing we'll say is, well, here's our standard 3-month no-cost agreement. Sign here, you have the software for 3 months. We'll come back and talk to you in 2 months' time and say, well, if you've liked it, then either we can do a project together to further develop the software, or we can license it over to you, maybe with some ongoing support as well. And we do also do training as well. So it's not so much about, I'd like to say it's a business model. We don't make a lot of money off our training, but it is another way, in principle, that you can look to kind of monetize software. I'm going to skip through those because they're boring flow diagrams, but they'll be in the slides if you want to see the nuts and bolts of how these things work. So, finishing thoughts. So I guess fundamental to any, going back to the question of how do you sustain open source software development, the first thing I think about is actually who do you want to use this software, because there's no point in spending the time, money, and effort to maintain a piece of software if nobody wants to use it, right? So think carefully about, who are your target users? Is it that you want other academics to uptake your software? Is it you want to have industry uptake of your software? And if you can identify who your users are, then that sort of affects what licensing choices you want to make for all the reasons I mentioned before. Absolutely talk to your local IP team, your tech transfer part of your university, to make sure that you do everything right in terms of licensing, so you don't expose yourself or your institution to any kind of legal liabilities. There's this sort of implicit idea here that always bringing in money from your software is a good thing. And I just put this comment here that it's clearly it can be a good thing to be financially rewarded for the work you do, but often if you have some commercial licensing agreement, there is some strings attached, there's some support. As I was asking the question to Mike earlier, well, if PartIV are rewarding royalties back to the Castleft developer group, what onus is on them to provide support? And you need to make sure you are comfortable with that balance of reward versus obligation. And finally, I would say, when I was working at EPCC, supporting academic uptake of software is relatively straightforward. People are often quite receptive. Supporting industry uptake of software is really, really hard. We've said this, I think it's been a theme across all the three talks so far. Having access to some kind of what I call sort of bridging funding that can help you take a code from something which is suitable and relevant for an academic audience, something which is suitable and relevant for an industry audience, whether that's the impact acceleration account, so that's like the fellowship scheme that was mentioned earlier. Most universities have something that might be called something like a proof of concept fund or some kind of seed corn funding for developing, developing prototype user interfaces, if that's your thing. Innovate UK have these competitions that academics can bid together with companies to push software up the TRL scale to the point where it can be adopted by industry. So these things help. But it is a difficult thing to do, and that's why we're trying to hire somebody at STFC to help us do that bit, because it does require lots of time and effort. So I'm going to stop there. I hope you find it interesting. Some useful thoughts there. Happy to chat.